Hello, Professor and everyone. My name is Tam Prohim, a combined master and PhD candidate from Mobile Computing and Networking Lab under the supervision of Professor Kim Sok-hon. Today, I would like to represent for my team, which consists of two main members, me and Chun In Sak. So our term project is mainly focused on a web application for automatic machine learning classification and visualization. So before going to our detail into our final presentation, I would like to capture a brief description on our project background. So in the next generation radio access network, there are multiple updated specification, interface and protocol to support the conversion between AI model and programmable networking. So in software-defined networking for programmability and scalability, we want to use our application by cooperating with RESTful API to update the control plane decision to ensure that the controller has the maximum capacity to optimize the network performance in data plane by using the OpenFlow protocol to install the flow rule entry proactively and reactively as well. So the more detail about the project background is that for now we're working on a SDN test bed that using real controller to install the flow entry and also data flow to the data plane. So before adding any new flow entry, we want to ensure that the configuration is have some intelligent control or intelligent orchestration to configure a value with high accuracy based on the previous experience of our network circumstance. So to do that is we move to our project goal. So the project description is our main tool that we use, such as Streamlit for web framework, web interface that cooperating with Python programming language, and NumPy for data input and manipulation and slicing the feature, sklearn to develop the supervised machine learning algorithm, Panda for data input and manipulation, and NumPy is for feature extraction. Actually both work together, as we may know, and Matplotlib is for the output and data visualization. So the project description is this is our flow by allowing the user to input the dataset, to set the machine learning parameter, to perform the classification, and to plot the data and accept the model for the showing result. When they get to a certified accuracy, they can accept the model and input the testing for us to output the prediction for them. So this is the more detail on each functional. So get dataset, we use NumPy and Panda mainly to convert the data frame and slicing between the general feature and target feature inside that input dataset. And get parameter, we use Streamlit and slide bar function. Get classifier, we use scikit-learn with multiple module and classification process. Plot data, mainly we use principal component analysis to separate and define the each axis. And the cell output, so as we use the web framework and platform, therefore we need to cooperate with HTML. So we will use base64 module to encode and decode the data, and OS module to access the path of and cooperate with the operating system. So our end goal is to get the final result and output for the user based on the model parameter that they configure and get the certified accuracy that they earn. So let's go to our quick demo. So for now we still use localhost because we cannot publicly hosting yet in terms of user authentication. So as long as we make the user authentication and we can separate between the data and of each user, we will host it publicly. So to run in local, we just use Streamlit run command, and we access it locally. So this is the main the first main page of our project. So in here is when we want to clear the cache of the previous dataset that we import, etc. So let's get started with the sample dataset. So these three are the sample dataset that we want to testing. So for example, like iris dataset, flower dataset from scikit-learn. So when the user select any dataset, they will we will display the shape of the dataset, 150 row and 4 column, the number of training target. So the number of training target is the target feature. This shape of data is only general feature. So the target, distinct target is 3. Is 3, and the classifier model that the user selected now is scan. So when they change, we will update the changing parameter in real time without refreshing in web. So when the user, for example, in this, I will try SVM instead. In here, the accuracy is only 55% with the C regionalization parameter 0.01. So the user can increase it to get a better accuracy, and then they can accept the model. So this plot, let's move toward the data visualization. We just use principal. We just use principal component analysis to separate the dimension of the data, and then we use the matplot to identify and map it and plot it. So let's move toward the upload dataset function that allow the user to upload their own dataset. So clear cache here is just to remove all the duplicated model. So I have two data here. Is the best. This one is the first data. Let's get started with this one. So when the user input the dataset, we will allow them to see the structure or to see the which feature to remove or to define as a target first before allow them to select the model. So let's say this. Let's see about this dataset. This dataset have this main feature, and the ID, as we may see, it is not affect or not important to the model. So we will have to clean it out, and the output here is the target feature. So the user the user will have the capability to define that. So the column to drop is just one of our main target, because in future work we will allow the user to select any data preprocessing such as standard scaler or binarizer or normalizer, etc. But for until now we cannot complete it yet. And next, the user can define the target column. So the output will be the target column. So after that, the user have the capacity to capability to edit their parameter to find the optimal accuracy that they want. So the data set, upload data set, and the shape of data set, the number of training target, which means that the distinct value of this column, and the classifier model that the user selected, the parameter that they set will be updated, and the kernel. For now we're using default kernel, so we use radius basis function kernel, and the accuracy is calculated for them when they change each parameter. So let's say the user prefer to use KNN, and they can slide here. And the data visualization is the same concept with the color bar. So let's start with another one and try to accept the model toward our end goal. So this data set is the server selection. So this dataset, the feature is in our networking, such as delay, G node B power, congestion window, and server selection. So for example, the user want to drop the ID and define server selected column as the target, and then they prefer reinforcement learning to perform the operation, and when the accuracy is maximum, they want to extract that toward their testing data. So the testing data here is meaning that the data that has no result to at all. So this is the output result that we execute. So when the user input the testing result, our function will take that result and append a new column named model prediction, and then each model prediction, each line of it will be using our CLF, which is our model, to predict each row, and then we append each row to our new column model prediction. So the final output is allow the user to download it, and the download is being processed in background. So CLF is mainly focused on the function that we set, that the user set based on their configuration. So this is the final outcome. So the model prediction here is the result. So with this feature, the user will belong to the server 4. So this will be the end of our term project, and in our future we will mainly focus on adding more algorithm and allow the user to perform more data pre-processing. For now we can achieve only the dropping column, but in the future, as we may know, that the real-time dataset is really challenging, and it is from multi-platform and multi-resolution. So we will add that for later on, and we also add the visualization choice, such as the user select histogram or scatter chart or some bar chart, etc. So that would be the end of our presentation, and I would like to thank you, Professor, for the valuable lecture throughout this semester. So thank you for paying attention. Thank you, everyone.